but we cannot able to connect through the Oracle client. We need to use only JDBC.
Oracle client to Spark, right?
Yes.
Yeah, Oracle client
Actually,
to Spark.
where,
Yeah.
so we need to use only JDBC.
Currently, Spark supports JDBC.
Oh, okay. Okay, right. Okay, maybe in the future versions, maybe it will use native tool.
Yeah, it will also change it, but currently it's supported by JDBC. That's what we need to use. But future support, yeah, it will change.
Okay. I know.
Yeah, Aru.
Yeah.
Can you see? Can we describe like what kind of challenges that you are getting in like real-time issues and all?
Yeah, we can. Hive, mostly Hive, I didn't face any challenge because there is not of things in Hive. Few of the things which we faced is the file, it is having 1 TB or 2 TB and 100 GBs of files will be there. And in order to find the error records, that was the issue. Like because of that, the MapReduce jobs will fail. So that was the challenge, and we have to write a script to like combat that issue. So we need to check whether which line is having an issue and all. So that was the one issue we faced in the real time. The huge file, we need to find out which line is not properly there. What all the data set is not there in the file. That's an issue we faced. And recently we passed around 1.5 years to 2 years, we were completely engaged in a Spark project. So there we faced a lot of issues. So once we start Spark, that time I'll describe what the issues I faced.
Okay.
No, like in mainframe or some right? If some job or some query is running, so someday it might eat up the CPU, right?
Yeah, correct. It will eat.
So, is there any scenario, something like that, if you are going to read 10 TB of data, is it going to be affect that other jobs, other MapReduce or something?
In MapReduce, there will not be such issue. We can specify that actually. Sometimes in Spark it happens. If we did not specify the total cluster size and how much memory it should take, it will take up the memory and other jobs will be in queue. So once your job is went to running state, then you don't have to worry about the memory because it will go into running only once it has the required memory. Else it will be there in accepted state only.
Okay. Is there anything can be done for the priority?
Priority, yeah, there are a lot of scheduling mechanism which we can do. First, what is it? There are priority scheduling is that one we can do, or first priority scheduling. Those things we can do in yarn setup. Yarn scheduling.
Okay.
We didn't see yarn yet. Tomorrow only we'll start the yarn, how yarn works and all. So after that you can check that one. How to schedule.
I take it, yeah, everything in my mind.
Yeah.
Why
No, we didn't see it yet.
Okay.
Which is a correct question. All the questions are very correct questions only. We faced everything in fraud only. This correct one.
Okay.
Mostly when we are dealing with large number of data set and all, we faced issue like connection issue, and in Spark most of the issues we'll get is out of memory exception. So that will get often in Spark, not in MapReduce. Spark, because Spark it runs in memory. Sometimes it will go out of the memory, so we need to manage it through our program sometimes, or we need to increase the executor size. Executor, I mean, there will be a container blocks. We need to increase the memory of that to like accommodate. Sometimes we need to reduce broadcast variables. So those things has to be handled in Spark in memory base.
So again, I'm going back to the first day session, right? You mentioned that this data can be used for the election kind of campaign here in US, right?
Yeah.
So there are a lot of chance to malpractice, right?
Malpractice in the sense, what is it? Which kind of thing?
So I can correct the data, right? For an example, if I have only 50 million supporters, then I can just move it as a 70 million, right?
Okay, but where will you change it? If you have own data and if you change it, what is that impact with the system?
No, nothing. So I can just copy the file and then put it to another folder, like.
Yeah, that is always possible.
Yeah,
Right? When we have data,
yeah.
it is possible for us to change the data and whatever we need. But when it goes to certain body, when it's governed properly by some authority, then we will not be able to change. That is the case here. Because the data does
And
not,
also
it's not authenticated data.
okay. If we change it because the next time the analytics they will not give it to us, right? If we lose the project, if we give a wrong information or wrong prediction, so there may be a possibility, right? Yeah.
Yeah. It depends on the luck, right? So if the person
Yes,
got win,
yeah.
that's it. Right?
Yeah. If someone want to ruin the analysis, they can do that. Yes, that you are right.
Yeah, that is correct only. And that's why they will go for the companies. That depends on the companies only. But the clients also, they will see each and every steps. Actually, when we were working in one kind of data science project, they will not believe whatever we say. They will say, like, they also will have one data analyst guy who will ask us which algorithm you used, what is the steps, and how did you arrive to the conclusion. So there are a lot of questions they'll ask. So based on that only they'll believe.
Okay.
Yeah. We are doing a lot of documentation, right, for the clients.
Yeah, that only they'll believe. So it is not.
Yeah.
It's not easy actually, but it can be done. But it's not easy.
Yeah.
Yeah. Okay. So we shall start today's class.
Yeah.
Okay. This is some already presentation, already programming guides. Okay, so we were seeing comparatively what is schema and read and schema and write, like uh, Hive versus RDBMS. So let's see whether recording is started. Yeah, recording is started. Okay, so when we compare with RDBMS and Hive, it is schema and read and it is schema and write. RDBMS is schema and write. It is, we always define the data structure and then only we'll insert. We will not be able to insert if we specify something as an integer column. We will not be able to insert string into the column. So it will throw error while inserting itself. So that is what RDBMS and that's schema and write. Schema and write is nothing but you can insert any data to Hive at any point at any time. Only while reading the schema will be imposed. So like yesterday we have seen, we had a different schema, different structure to only one line. While reading only, it applies the schema and try to read it. Even though it does not have the data for the other columns, it shows just null. So those kind of issues is common when we go for Hive. We need to validate the data and we need to remove nulls if in case of bad data and all. So that we need to do in a layered approach. First layer, we will have the source data. We will not touch the data, will not change it. Whatever is there in the source, we'll just keep it in the layer 1. In layer 2, we will validate it and we'll have the proper data, whatever we need. So those are the things we need to be careful with. And regarding updates and transactions, Hive is not useful for that. Like we will not be able to do row level updates in Hive. Even though currently it is available after 1.2 version, it is not much faster or it is not recommended to use Hive for that purpose. And transaction, obviously, yes, Hive is not for transaction. It's not like immediately when the transaction is made, immediately, okay, you put the data into Hive. No, that is not the case for Hive also. And data types, there are a lot of data types available. But when we go for the first layer of layer 1, when we go for layer 1, which is coming from source, we always give all the columns as string only, because we don't want to miss any data. Like all the columns, we will create table with the string. We will not use any data types in that first layer of table. As far as production or any real-time system is concerned, we never used any other data type, because we don't want to miss any data. If we give something like integer or small int, and if the data type is mismatched, then it will throw an error. It will not throw error, it will show just null, simply null. So that will make us lose some data. So that is why we will not use any other data type in layer 1. Layer 2 and all, based on the projects and based on the requirement, we might use the data types like begin, float, double. Those things we'll use based on the requirement in layer 2 levels, not in first layer. Okay. And there are some complex data types as well as simple data types. Simple data types is Boolean, string, and binary. That is int or these things. And complex data types are same as RDMs only. We have map, array, struct. These are very common data types. Same how we are using in the RDMs, it is also same only. Like this is, we can use this as arrays, and this is map. We can use this map and struct. Those things is possible. Fine. So that's all basics about data types. And what are the operators we can do? Hive has its own functions, like aggregated functions. It has like sum or average. Those functions are built in Hive itself. So if you want to know some function, we can do show function and we can see. And if we wanted to write some custom functions, let's say I have some specific function which I want to write a code and implement it. That is also possible. That's what we call it as UDF, user defined function. So in what all the cases we will go for UDF? If the function is not available in Hive, and if we want this function for specific reason for our project only, if we need some function in Hive for specific needs of the project. So in that case, we will go for user defined function, UDF. So in UDF, we can write UDF in Java or Python or Scala also. That language we can write, and mostly all the scenarios, whatever we've seen, we wrote the user defined function in Java only. So we can write and add the particular function into Hive, and then we can start using. That we'll see how to do this. And as same as RDBMS, it also has implicit conversion. So if we give float and it can convert it into like integer to number to integer and string. If we give string and then we can convert it to integer, and also as well as we can change it to timestamp also. So date conversion, those things are possible using cast function. We can do cast and easily change and play with the date format, date function, changing UTC to IST time. So those things is possible used conversion. These things are common in all the RDMS as well as same as Hive only. It is not much difference. That's why we're just going. Yeah, and some of the things which is important is how can we import the data? This we have already seen in some examples already. So we while inserting into another table, we already saw how to insert and all. So from one table we can insert into another table. So that's what we have been seeing. For example, this one. So we created multiple tables, and from this table we are inserting into this table. So that is one way of importing, which is we can call it as a layered approach. First layer is, this is the first layer 1 table. From here we are inserting into the next table. This is the layer 2. So how we are doing is just selecting it. And the second table is a partition one. So that is a way we are using it, and it can be used in multiple use case and multiple scenarios. For one example is whatever we have seen is we have created one partition, and then in the partition table we are inserting the data from the source data. Source data is also available in Hive only. For example, so this is the entire Hive only. Let's take this Hive table. This is Hive environment. This is Hive, and this is the layer 1. The source data is entirely replicated here. The source is entirely here, which is Hive layer 1, table 1, layer 1. Okay. So here the ditto will be here. Whatever the data is outside we imported, the same will be there here in itself. And then the next layer, we will insert from here to here. In that table, we may create partition or bucketing, whatever we want to do. We'll do the operation and we'll insert the data into the layer 2. Optimization. In some case, we may delete this data. We may delete this and use it as a staging. Once the data is loaded, we may want to just delete the staging table, layer 1, and we'll keep only layer 2. Because layer 2. We'll just keep the layer 2. Okay. So these kind of things we will do. And here, one more thing also we need to consider is, if we are going to delete this table each time, we will create this table as a managed table. Because we are anyway going to delete the table at each time. So we'll create this as a managed table, this as an external table. So everybody understood till now? We will use layered approach. Anandji, Anbuji, and Ganeshji, Selvanji.
Yeah, yes, I'm fine with that.
And Vigneshji and Cheramji.
So it's the same as the concept of managed table and extended table.
Yeah. Same managed. I'm just telling where we are using managed table. At what scenario we use managed table. This scenario we use managed table because this table we will delete. This staging table we will delete after some time. After the data is loaded into layer 2, we will delete the layer 1. So in that case, we will use this as a managed table. It is not mandatory, but it is just a usability purpose. It is not mandatory. We need to use managed table, but it's for.
So if we delete the managed table, the entire data will go away, right?
Correct.
Okay.
Entire data will go away.
Okay.
Aruji, this everything is saved in HBase or
HDF.
like it's in HDF only still.
Everything is saved in HDFS only.
HDFS only. Okay.
Yeah, it's HDFS file system.
So I just forgot what is staging. Can you explain it?
No, staging is it is not related to Hive or nothing. It is a process. While processing, we say it's a staging table. Staging table means somewhere where the data is temporarily available. It is staging. We call that as a staging table. It is a common term in any RDBMS system. Staging means it is kind of temporary table. You can assume like data is there in staging one. The intermediate processing table is what called as staging table.
Okay, thanks.
Here I'm calling it as a staging table because once the data is from here, we'll just replicate it. After we'll copy it to layer 2. Once it went to layer 2, we are deleting the table. Since it is an intermediate table, we are calling it as a staging table.
One quick question. When you have the layer 1, you said that everything is string type, right?
Yeah, exactly.
So how do you ensure that when you move to layer 2, the appropriate translations are happening?
Actually, mostly in layer 2 also, we will not change. They will not deal with data type much. Yeah, unless or until we need specific data type, we will use. Else, we'll use cast use. To while read it, we'll impose a schema. But here we can write our query here. While doing it itself, here itself we can write a query and we'll make sure the data gets over there properly. Because here also the issue might happen.
No, so even to cast the data, you should know what data type it should be casted, right?
Yeah, correct. For that we need to understand the data, right? What is the table? What is the
where
column?
is the metadata of that is stored then? For example, when I'm loading data into the staging layer 1,
okay,
some of them may be date, some of them may be int, some of them may be string, right?
correct.
So everything is now stored as a string. So when you move it to layer 2, data that is stored, the int data that is stored as a string,
correct.
that information should be there for us to cast it, right?
Yeah.
So how do I know that?
If we want to know, we need to go back to the RDBMS and find out, or we need to have our metadata from BA to get it. Then only we'll be able to know. In system, we will not able to get in Hive itself. That information we need to get from RDBMS. We need to go to the source and find what is the data types and those things. Or we need to see the, we have the mapping document, right? In the mapping document, we will be able to find.
So when you write the ETL, integration routine from layer to layer 2, so you should know how do you have to translate it, right?
Yeah, exactly. We need to know. Correct.
Okay, thank you.
Because here mostly the business logic will not get involved, but if in case it is involved, then yes, we need to refer the business document, mapping document and all, then only we will be able to translate. Okay. So
I have a question on the managed table.
yeah.
See, everything stored as a HDFS in a file format, correct?
Correct.
So I think in earlier class, if I remember correctly, we cannot delete the files in HDFS until otherwise if you go and do it through the Unix command or from the Linux side, correct?
Okay.
Within HDFS, we cannot do any file manipulation. Is that so?
Yeah, correct. But we cannot do any file manipulation, means we cannot edit the file, right?
Okay, but we have
we cannot edit, but here what we are doing is we are creating one more copy. This will be a new copy of the file.
No, I got that point. I got from staging to layer 2, I got it. My question was that how are we going to delete? That's where I was just thinking.
Okay. No, then the point was actually wrong. We can delete. If we delete the managed table, the data will be get deleted. If we drop the managed table, the data associated with the managed table will get deleted.
Which means if you have permission to delete the file, we can go ahead and delete the file.
Yeah. No. We don't have to go and manually delete the file if we create a managed table. If we drop the table, the data will automatically get erased.
Okay. Then what will happen to the see the data in the sense that metadata will be erased, but the file in that, how it is?
Okay. No, what is the difference between managed table and external table? Do you remember?
Yep. Basically, managed table, we don't have the copy. So once we delete the managed table, it will permanently get deleted.
Okay. Metadata and data will get deleted. That is the point.
Metadata and data will get deleted. Whereas external, metadata will be there.
Correct. Metadata only will get deleted.
Yes.
Okay.
The data will be there, so we can create the table and we can import the data for external.
Okay. No, here your understanding is correct only. Metadata and data will get deleted in managed table, right? So anyway, the data associated with the same table is get deleted, right? When we drop the table.
Yes.
Then what is the question, Ji?
I think I'm looking from the file perspective. Are we deleting, because everything table is for our reference, but internally it's stored as a file.
Exactly. Correct. When I mean the data means files only. Files only it is stored as, right? Files also will get deleted in managed table.
Okay.
Here only the metadata will get deleted. Data will not get deleted.
Clear.
Okay.
So the metadata which is stored in the RDBMS, that will be deleted.
In external table, right?
Yeah, for external table, all the Hive tables will have a metadata stored in somewhere in the RDBMS.
Correct.
So when you delete from the Hive, that will be go and delete the metadata from the RDBMS, not from the anywhere in the Hive. Is that correct?
Yeah, exactly. That is right. So anyway, why do we need to have managed table here? What is the purpose here means? If you can have external table here, yes, you can have external table. But what you need to do is then again, you need to delete the metadata once, again you need to delete the data once. There is a two work. So instead of that, we can have metadata so that it can delete easily. That is the reason we have managed table here. It is not mandatory. It is just a use case purpose perspective for usability. Understood, Ji? The use case and scenario.
Yeah. Yes.
Okay. Okay. So those times we might need to do that, and sometimes what we need to do is we might need to do multi-pass insert, which means we have one large data set, which is having one, let's say 100 GB of data, 100 GB of data, and we need to insert this data into around 10 tables or 5 tables. Let's say 10 tables we need to insert. So this we can do while scanning the table one time itself. We can insert into multiple tables. This is actually I'm sure you might have did the same in RDBMS many times, but same is possible in Hive also. Like what we need to do is we just need to scan the table from, and then we need to insert into multiple tables based on the conditions. It's very simple only. Multiple table insert, and then from records we need to give. It's a table one which is master table, from where we need to start, and then we need to insert everything into table 1, table 2, table 3. Accordingly we can give the conditions here. That's what we call as multi insert. Let's say multi insert, we should have it here. Multi insert example, it is not there. Okay, it is not there, but anyway, the same syntax only. If we can just scan the data, like just scan the big table one time, while scanning itself we can insert into multiple tables. That is also possible. That also we will do in terms of transformation. We will have source, and then we can insert into only not one table, the another two multiple tables we can insert. The data can go to many tables. That is also possible.
So because of the it's unstructured.
No, it's not relatedly unstructured. We can decide to have, okay, you may have the data coming from all the regions. Let's say you are dealing with world data. The world is separated by regions in terms of projects. So you may wanted to put, okay, North America region, I want to put in some specific Hive table, and I will give access to one specific team. So something like that. North Indian data will give, and North America NAM, North America data will give, and Europe data. Currently there is a issue come, right, like GDPR. Anyway, it's not related to that, but still, if you want to put some other data, NAM data and Asia data into some other specific Hive or another specific Hive table, and you can give it to specific access to them, something like that. You can. It's a manageability, right? It depends projects to projects. That is possible. You got it, Ji?
Yeah. Okay. Yeah. Now I got it. Now it's from the RDBMS. You take the data and you create separate tables in the Hive and you insert the data.
Correct. Yeah. So whatever we are saying is just a use case. It is not mandatory. This is going to only be this way. No, it can differ based on the project, based on the requirement, based on the clients. So it differs. Sometimes what happens is there will be some secured area. Secured area. where you will put those data into those secured area. What is means PII, like personally identified information data, which means the ID, right? We have Indian, we have Aadhaar card, right? US also something like that is there. I'm not sure what is the exact meaning. Like some ID is there, right? What is the ID name?
SSN.
Yeah, exactly. SSN numbers and those details. It's a PII information. That's sensitive data that you cannot simply store into Hive table and give access to everyone. No, that is not possible. So for that, what the projects are creating, what we are doing is we have some secured area which access is restricted to only specific teams and specific team members. So those details will be put in there only. So for that, what is that? It will be some different area. For that, we need to write into those tables only. There are some other procedures like that. So those things also we need to handle. Something those sort. SSN number and all. So for that purpose, we might need to put into some other multiple tables. So for that, that transformation also will happen in this layer. Okay, that is also possible with the layer. That is also use cases. And some other use cases, you may receive the data in text file here. Text file, you may receive data text file here, and you wanted to change the way the data is stored, which means you are going to use some other compression techniques. Compression techniques to store the data. You want to change the way the data is stored. Data is there in text file format, and let's say you want to store the data into ORC file format. So what is ORC file format? It is an optimized row columnar file format, and it will save a lot of space. So that is what we call as ORC file format. So with that, if we want to save the data in ORC file format, we cannot directly push the data as a ORC file format data. For that also, what we need to do is we need to transform it here only. Then only it will store it as a ORC file format. For example, we have the data here. In first layer, we have everything as user info ORC. User info. From here, if you want to create it into ORC, all we need to do is we need to create a table with this is the keyword which we need to use, stored as ORC. Then it will create a table saying that okay, I am going to create this as the ORC file format. I'm creating the table first. Hive. So the layered approach, there are n number of things you can do in layer 1 to layer 2. Mostly 60 to 70% based on your project needs and business logic and how to store, who is going to consume the data, and what kind of formats, what kind of partition, what kind of buckets, why do you need the partition in that way, and whether it has any PA information, whether it is secured, those things, everything it has to be considered. So I'm just creating the table. Yeah.
One question. Like, can we do on any scenario like do you guys do like directly copying from scooping from from the RDMS table to directly to the external table?
What is it? Which
do we do it direct? Can we do directly from RDMS using a scoop from RDMS to directly do external table rather than having a managed table?
Yeah. That is also we will do based on the requirement, based on your scenario. See, if you want, this is for usability. You understand, right? Why do we use managed table here?
Right. Yeah. We say
yes. So same way, if sometimes you never want to delete the data. Here I'm using this as a staging table, and it is going to get deleted each time. Once the layer 2 is loaded, layer 1 is going to get deleted. If in some cases I don't want to delete the source table also and external table, next table also, in that case I will make this also as the external table, so that I don't have to delete it. Here also incremental load will keep on happening, and I will just take the incremental data from here and I will put it into layer 2, so that everything will get always in a sync manner. The sync will happen. So that is possible. So those cases will happen if you don't want to delete the staging table. You always want to keep this table also. You always want to keep this table also. source table also will have all the data all the time. So here, from here, you will just take the incremental and put it here. In that case, we'll make this also as a external table. Understood?
So it's like every time you take the backup and put it there. So then you keep that managed table live.
Yeah. No. We'll make it as an external table in that case.
Oh, okay.
We don't have to go for managed because we are not going to delete.
Okay.
For usability purpose only, we create as a managed. We don't want to delete the file manually each time. That is why we create it as a managed table. Now we never going to delete, so we'll make it as an external table.
Okay. So that way there will no. I mean, we will eliminating a managed table, so we will have a directly to external table.
Yeah, we have a directly external table. Yeah. Okay. Got it, everybody, and Anbuji, Ganesh, Selvam, and Shivaram, and Vignesh, Anand.
Yeah.
So everything, whatever we are seeing, it is the use cases and the like project level perspective. How do you know? Like how do you do? This does not come. There is no one solution for everything. This is based on the project requirement. If they want in that way, we can suggest this one. If they don't know, I want to keep the source table also because I have a lot of HDFS and for data security purpose something. If they say, then yes, we can create external table. And also it's usability and it's a kind of architect thing, right? It's not we can go for this, go for that. Like architect has to decide. Okay, here just example how to create ORC files in Hive. So I created a one table as stored as ORC. Initial file we have the data as a user info as a text file. So I can just insert from this table to that table, then it gets stored into the ORC file format. I can just inserting. Table not found. Why it's table not found? Okay, the table is user info. Next. Okay, give me a few minutes. I'll be back in a few minutes. Yeah, sorry guys. Yeah, so it created the Hive ORC file. let's see how the file is stored in the folder. User Hive sub user info.org. Just copying, coming out of Hive thing. Clear. Yes. So here the data is there, and we will not be able to see the data. Like it will be in a different format. That's what we were expected to see from this data. So yeah, so it is a compressed format, and it is stored in a ORC format. So that is being created by Hive itself. And this exercise, this particular thing, it will not work in the 4.4 version. If you are using the Hadoop 4.4 version in your machine, sorry, like Cloudera 4.4, this will not work. This is available only after 5.8. Okay, so how to check the Hadoop version? Like this. Hadoop version. You are using these things. Hadoop 2.6.0 we are using, and CDH 5.13. Okay. Okay. So any doubts, any questions till now?
So our text file will be like will change it like this .org.
Yeah. Correct? So our command says our text file is, we have a text file format in user info that is changed to ORC. Correct. Our text file remains the same in the same table. This is a new table.
Okay. So the only using the SQL commands only we can read the data.
Yeah, correct. Only using the SQL command only we can read the data. There are some other examples there. Hive UDF script and all. Okay, we'll try to create a Java program and UDF table operations. Okay, we can edit the alter table and column name. We can add or remove. Those things are also possible. And if we change the metadata and if we refresh it, it has to have the same data. It has to match with the data, else it will show issue while reading it. That will happen. And there are joins, couple of joins. We can use inner join, outer join, semi joins. So inner join, outer join is common, I believe. So it is like left outer, right outer, those things also available. So semi joins. What is semi? I will. Yeah, let's go for semi join. So semi join is nothing but it is the replacement of in SQL. Like sometimes we may do the subqueries, right? So I'm just skipping the inner join, outer join, and those things. I believe everybody has understanding of data warehousing and SQL concepts. So semi join, I believe this is also available in Oracle, right? Is that Soji? Anybody? Ganesh ji or Anand ji? Semi join is available in Oracle.
Yeah, we can use the in.
Basically we use the in one. Any
Yeah.
join we use in condition.
Yeah.
Correct.
Yeah.
So,
or you need to use exist.
Exist, yeah.
Okay.
Not exist or exist.
Okay, sir.
If you want highly performance, then you need to use exist. If you don't need to worry about it performance, then you can go for in class.
Okay.
Or between class also, no?
Between.
Yeah.
Okay, fine.
A better performance means then only exist.
Okay, so semi join is, but semi join the same syntax is there, or only we need to use in?
There is no semi join.
In only.
It's only in. Yeah, in exist, not exist, like
Okay.
that only you can use it.
Okay, got it. So here instead of in, we can use the semi join. So semi join, it works the same way what in does, but only thing the same way only. It is not like, but we will write the query in such a way, like instead of in, we need to write it as a semi-join. It is the same as in. And also it is same as we will not be able to select the table 2's other columns. Like the same way, if we do in, it just checks the whatever the data inside. Like I have some kind of data x, comma y, something like that. Or I may have the SQL queries also here, right? In I can do select ID from table 2. I can have something like this. So this will give some results. And this result will be checked against the one which is there in the main query. Select star from table 1 where ID in ID2. So this is a kind of in statement I would write in SQL. So the same thing we can translate into semi-join like this in Hive. Instead of where ID and all I will do is I will do semi-join, and then I'll give table 2 here, on T1 T2. Let's have T1 T2 as T1 as T2 ID T1.id is equal to T2.id. Fine. So this is the same way. Instead of in, I can use this one. So that is also one of the way to approach in Hive. And one more special join is available. That is called map joins. So map joins is a special join actually. Map join. So if let's say we have two tables, we need to join two. One table has more data. One table has around 1 TB of data, and second table it might have the data of 100 MB or 200 MB dash. Let's say that's 200 MB. In that case, I can do one kind of optimization. I can use map join to bring this 200 MB into map itself. This is a map side join. This entire 200 MB will be put into my memory itself. It will go into all the executors. This table area, instead of getting streamed, the entire 200 MB will go into all the executors. If we mention this a map join. So let's say this is my cluster. I'm drawing the cluster diagram right now. So this is one data node, this is one data node, this is one data node. At the end, even if you write the SQL query, it's going to write the map reduce jobs, right? Fine. So if I mention a map join, the small table will go into each executor. One copy will be sent to the each executor. So here one copy, here one copy, here one copy, and the other table will get streamed from HDFS. Other data, let's say the other 1 TB, here 500 GB is there, here one 250 GB, here one 250 GB. So this join will happen here itself. That is what we call it as a map join. So if we mention map join, first of all, when we need to use a map join, when one table is small, it is very small so that it can be accommodated into memory itself. That is the first case. In that case, we can use map join. If we use the map join like this, then what happens is the small table will go into all the executors. Wherever this map join is running, from there it will be used. It will be kept in the memory. So in that time, we will use the map join. And map join will go into all the executors memory. Wherever the map reduce job is running, it will go there and it will get joined with the other table. So this join will happen in map space itself. It will not happen in reduce space. If you use a normal join, that is a reducer side join. So this is a map side join. So everybody understood this concept?
So the data will be joined.
Yeah, data will be joined. Only thing is, the data will get broadcasted.
Okay. So, but the mapper will, by default, the mapper will do that, right?
By default, mapper will do that. But what happens is, by default, mapper will stream the data. It will not hold the data into the memory of each executor. That will not happen in the normal time. as and when required, then only it will stream the data and it will process. But here the entire data will come here. It will be stored in the memory like RAM. If you see this table 2, only 500 MB is here, like 500 GB is here, 200 GB is here, 200 GB is here, sorry, 250 GB, let's say 200, here 300 GB is here. It is not entire data, right? Only 200 GB is joining here, here to 500 GB is joining, here 300 GB is joining. If that does not happen here, if the 1 TB, entire 1 TB, we will not be able to store in all the memory, right? So that will not happen. Here the join is possible. This 500 dB, okay, that will get compared with against 200 GB, 200 MB. So that is possible. Here itself we'll do the join. In here itself, entire job will get completed. You can see that here itself the entire job will get completed. The 500 GB will get joined here, and we'll have the intermediate result. Here also we'll have the intermediate result. That result is almost the final result because entire join happened here. Okay. So the same concept in MapReduce, we call it as a distributed cache. It's also the same concept. Distributed cache is nothing but if the data is small, we can do it a caching. It will go into all the executors, executors memory. It will go into all the data nodes memory, and it will stay there. Entire one data copy will be sent to all the executors memory. And this concept is available in Spark also. That is called broadcast variable. So this concept is there in all the everywhere. Like it is, we in Hive we call it as a map join. In MapReduce we call it as.
So basically, the map join is nothing but a left outer join, correct?
Left outer join. No. It's not left outer join.
See, the operation wise I'm talking, because when you want to do 1 TB versus 200 MB, then we can go for a left outer join, correct?
Okay, in that case, whatever the data is there in the right side will go into everywhere, right?
Yeah.
Yeah, in operation wise, you can say that. Yes, then if that is the case, then yes.
Whereas we cannot make any other join, like full outer join or any join, we cannot make it with the map join. Because that will be more, if two tables are more volume, then we cannot go with that. So basically, for map join,
if two tables are more volume, it is not possible. Only one table has to be less volume. Then only we can go for map join.
Yeah.
And map join is not a join itself, it is a concept. The join is happening in the other here. If you see, the join is here. Map join is nothing but we are mentioning, okay, if we mention it as a map join, it goes into the memory of all the executors. That's it. One copy will be sent everywhere. That is the concept.
What is the things? Is it a column name or what is that map join?
It is a table itself. Things is a table.
It's a table. Okay.
It's a table. Entire table will get streamed. It will go into the memory RAM.
So before join, it keeps the table in memory and then does the join.
Correct. Yeah.
Okay.
Yeah, correct.
Okay, got it.
Okay, and also we can have subqueries and views also in Hive. Okay, so any others have any other doubts like Anbuji, Ganeshji, Salumji, Sivaramanji, and Vigneshji?
Just missed the last part from the notepad, not here. In the notepad.
Here.
The distributed cache and broadcast variable. Okay, I got the Hive. MapReduce does the distributed cache. Okay.
The same is called in distributed cache in MapReduce jobs.
Okay.
And the same is again called in broadcast variable in Spark. If you mention anything as broadcast variable, the same happens over there. But you might have a question, already Spark is in memory, then why do we need a broadcast variable? Correct. So that will get answered in Spark. Anyway, to give you a short idea, what happens is, if even though Spark is in memory, you will be able to process more than what memory you have. Let's say you have 10 GB of RAM, you will be able to process like 100 GB of data. It is possible. It is quite possible. That's because Spark does streaming. It's not entire data has to be in memory all the time. No, it's not needed. It will work in a DAG way, and then it will process whatever the data required. Only that will go into the RAM at the time. But it does in a different way. Once the entire data processing is get completed, then it will write into the disk. So that is the way Spark is working. But if we mention it is in a broadcast variable, the entire data 100% it will stay in the memory all the time. Like till the job executes from the start to end, it will be staying in the memory all the time. And all the executors, wherever it is running, everywhere it will store. So that is a difference between, that's why we need to explicitly mention as a broadcast variable. And that cannot go beyond the executor memory, because it's going to reserve a memory always. It needs certain requirements. Okay, we'll go into the details while we go into Spark, because once we understand how Spark works, then you will be easily understand broadcast variable. But the point here is, yeah.
Sorry. Since we talked about a join in Hive, do we have similar setup in HBase as well?
HBase, we don't have joins in HBase. No. HBase is meant for different purpose. We don't have joins in HBase.
But it's also does the transaction no?
It is a transaction DB. You can say it's a transaction DB, but it is not for aggregated. It's not for joins. HBase is not used for aggregation, right? It is specifically used for key value pair. It's for it's random access DB. As we saw in that day, Hive is sequential one. You can do aggregated operation and OLAP operation. Those things are possible in Hive. For that we use Hive. But where we use HBase, it is like you wanted to find one data. It's like finding a needle in a haystack, like that. You can quickly get one data, you give one key, you get the results, like that. Like how you are doing the Google search, same way. We give one keyword, immediately the results of the keyword should come. We don't need to do an aggregated operation, nothing. No, it's not like that. For that only we need to use HBase. But whether we can do joins in HBase also in different context, yes. But we don't have to confuse with Hive. So that's why I said there is no join. But there is some joins which is not the join which we are talking. It will be very expensive, and it has to understand a different context. It's not the same context how we are discussing Hive.
Okay.
Because we need to understand the structure of HBase first, like how it is stored, what is column families, what is column, what is row key. Because that day we saw some while seeing the entire POC, but that is not enough. We need to see how row keys are stored. With the row key only, everything is managed there. Anyway, I don't want to confuse more without giving a clarity of HBase.
One question: HBase is a columnar table or a normal one?
Yeah, it's a columnar. It's a columnar NoSQL DB.
Okay.
HBase and Cassandra, these two are columnar.
Yeah. Okay.
These two.
Just heard the word Cassandra. Okay.
Yeah, you might use in Cassandra or HBase. Either one, mostly popular columnar. Okay.
Okay.
Yeah. So So those are the things which we need to take care while doing Hive. Mostly all these things we will be required in a project if we are going to go some in a project. Okay, let's say we are going to take some project, Hive project. What all the things we will be considering? What are the things we need to consider is file format and how the data flow, how the data is going to flow from top to here. That we need to consider, and what is the frequency of file, frequency of load, whether it's incremental or how incremental is going to be handled, whether the data is going to come from scoop or what is the way. Those things and all we need to consider. Based on that only we can optimize the data or we can design the Hive tables. So file format is a one point which we did not discuss yet, even though just we saw how ORC is stored and all. We did not discuss file format deeply. That we will see. We will discuss. Actually, one of my friend is working in a recent Hive projects, so I thought of asking him to give a session on file format because he is working in real time, so that he will be able to share more things. Recent Hive projects, like in the latest version. So I'll just arrange the session from him. Hive file format. Okay. So any other doubts in Hive? UDF also we'll see. UDF is nothing but there are multiple UDF functions are there. User defined function. One input, one output, we can write a function, or user defined aggregated function. It is like average, finding average, sum, those things also possible. And user defined table function. That is also possible. Table function is nothing. It is like one simple string, we may have to split it and put it into multiple strings. That is that kind of function is also possible. So sometimes you may receive a string something like this, is dollar something like this. You may want to separate it. For that, if you want to write a function based on your business logic, then you can write a function and that will give you a lot of results. Let's say expurge and the column. It will give the number of columns. It will just split it based on the special character and give the results. Something like that. We will write on UDF and we'll see. We already have the data and all, but currently we are today running out of time, so that we'll stop the class here. But we'll see it. We'll see it tomorrow. How to write the Java function. So any other doubts till now in Hive? So the entire point is Hive works in Hive does not own any data. The data is stored in HDFS or HBase, but we can create external tables of Hive and then we can access the data. So Anandji and Buji and Ganeshji, Selvanji and Shivaramanji and Vigneshi.
Yeah, I have to go through first.
So the material we have it in our session.
Yeah, it's there. It's there. Material is already there. Sorry, go to session information. Inside PPT, you have Hive. Where is it? Hive introduction is there. And assignments, Hive. You have the data. This Hive steps are there. Hive UDF and practical you can ignore. You can just go through on Hive steps.
Okay.
Okay, and if you want to go more further details, you can use this one, Hive Lab. This has a lot of lab exercises. How to do join, UDF examples, everything is there. That is just for example. And this is Twitter data practice. This is, we have on Twitter data and how to process that in Hive. This is kind of semi-structured data. So this kind of data, how to process in Hive. Those exercises also available. It's like it is there with the step-by-step practice. Those you can practice. Okay. Okay. So tomorrow probably we will try to finish UDF and we'll start with our yarn. Yarn is also one more important concept which needs to be understand how that will give us overall idea of how things works. It will be very useful when we were going to start Spark, because most of the Spark implementation runs on Yarn. Yarn is 2.0 actually, yet another resource manager. Tomorrow we'll try to start it and finish. This is a very important concept. So I'm going to do it like that.
RJ, one question. So we use Spark. So is there a way I can find it out of what yarn is running? Because this is the first time terminology I'm hearing it out. So is there a way we can see it?
Sorry, which yarn is running?
Or whatever that you are talking, the version or yarn, is there a way I can find it out if I have a Spark on my Hadoop?
In your like production cluster or in own cluster?
I have my dev cluster as well.
No, in Office, in your own laptop, whatever we installed there.
No, in Office only I'm telling.
In Office, right? In Office, if you want to find out what is the version you are running, check what is the Hadoop version you have. One easy way is, what is the Hadoop version you are also running CDH?
No, I don't use CDH. I use MOBA Xterm. There I can go to Hadoop.
MOBA
Xterm.
What is that?
Actually, basically like a putty or any.
No, that is fine. Putty is fine. It's a kind of putty, that is fine. If you type Hadoop version, what is the result you are getting?
Okay, I can get it.
Today you can check that one. From that you can check. There is one way, or other ways you have to go to where is the Hadoop. You check here what you have. So, do you run Hadoop jobs in environment?
No, we just use that as a platform.
Okay, then this way you can run. If you use CDH, whatever the version is coming, from that you can get to know what is the yarn version it is configured. Or other way, if you are using Cloudera Manager, that is simple. But if you are using something else, then we have to go here and find out. That is one more way of finding. This is the yarn. Actually, this is a web UI. If you run a yarn job, this is a web UI. But I believe you might not have the link to this. Go to this link. Here we go like this. But in Office, you need to hit the link for this. Do you use UG? Do you use U?
No, we don't use any Cloudera or any platform on this one.
Okay, one way is this one way, how to find it. Or do you know where the admin sits? Like, do you know admin of the cluster? Admin team should be there, right?
Okay.
We need to ask. We need to check with them.
Fine, Arjay, I can offline. I can check with you because this is something deviating from the discussion.
Yeah, sure. Okay, fine. Let's try this in your putty session and see what is it you are getting.
Okay.
When I try to comment, I will not able to. Yeah, Anandji, what is the issue, Ji? You can share the screen if you want. We'll try to fix it. Yeah, for others, I believe if you don't have any doubts, thank you for attending today's class. I hope today's class is useful and interesting. And we'll see tomorrow class. We'll meet everyone in same 7 o'clock. We'll see, and our 7 o'clock only we'll see. This is the correct time actually for me also to get up and work. Yeah, and file formats and that thing we'll see in a later classes. I'll schedule the class with the who is working in the lifetime. Okay. Thank you. Thanks everyone. Yeah, Anand, you can share the screen.
Yeah, thanks, sir.
Yeah, thank you.
I'm sharing.
Yeah, okay. Okay. Yeah.
So, are you able to see my screen?
Yeah, I can see. Okay, here there's an issue. Okay.
See, basically in the first, I have an issue here. I cannot do my put or get command
Okay, put
because
what is it? Put.
because okay, I'm just simply trying. Okay, so let me first.
Okay.
So what I'm trying to do, I have a file called tutor-data.txt. I'm trying to just move this file to.
Right? Okay, fine. Enter. Okay. No, the issue is you don't have the file. Where do you have the file? Put ls. No, put ls.
Okay, the file is here.
Where?
The
You have it
file,
in desktop, isn't it?
no, I have. No. Let's do this. Okay, so I'm trying to put this file. Text to that. Not in the Hadoop. Hadoop. This is my right. Yeah, so I have a file here.
Okay. Path. Oh no, you are having a file in Hadoop, not in local, right? You are trying to get the file or put the file.
I'm going to put this file into somewhere here. I want to move this file to here.
Okay. In that case, you shouldn't use put. You should use cp command.
Okay.
Because from Linux to Hadoop, that we need to use put. What we are trying to do is we are trying to copy the file in one location in Hadoop to another location in Hadoop itself.
Okay.
For that, it is the same. You are not changing any file system there, right? You are just moving the file from one place to another place in one file system.
Okay. So now you're saying that. Now you're saying that. Now I can. Okay. So now let me do this one then. So I have a file called text2 here. Okay.
Yeah, yeah.
This is in Unix.
Okay, that
Linux.
Yeah.
So I was trying to put that one.
Okay. Use keyboards. It will work.
So text. Okay, test2 dot text. Yeah.
Test2 or 1G. Test2 or 1G.
Okay, two. Text2 dot see space. I want to put the 1.2 in the Hadoop file.
You can, yeah. Now you can. No. Okay. No. Wait. This test2 is there in local, right?
Right. That's in local.
Local. The path will be /home/Cloudera, not /user/Cloudera.
/home is my home is this is my home. When I try pwd, it says I'm a user /Cloudera.
No. Go a little bit up in your screen. Scroll the mouse and go up. Wait. Yeah, that is /home/Cloudera only. If you do pwd, it will show the entire path. It is not user like Hadoop file system only has user. Here we have home.
Okay, so now you're saying that I should use a home.
Yeah, home/Cloudera/ this, and then target you can use the /user/Cloudera.
/user/ That's all right. Oh,
yeah, that's all. You don't have any other folder. Yeah, you have Anand 123 there. Yeah. Yeah, okay. You can enter.
I think okay. I was trying all the time.
Yeah, it went
with the user. Okay.
Okay. That is the case. We need just type pwd. Yeah, it shows where is the current location, like print working directory.
So now, okay, so if I want to go to Hadoop and try, how do I go to Hadoop? Like there's a sudo command. Why do we use a sudo command?
Sudo command is for super user.
Oh, okay,
Nothing
nothing for.
to do with Hadoop.
Okay.
You will not be able to go into Hadoop file system as such here from here. You always used to do Hadoop FS and then do this.
Okay, so but again, everything I do in a Linux only.
Correct.
Using
Everything
Linux.
we do in a Linux only. We just put the data into Hadoop and retrieve it. That's
So
why we have put.
So if we are going to Hadoop, means just only we put the command Hadoop will differentiate the Hadoop and differentiate the Linux.
Correct.
Right. If I don't put on Hadoop, then I'm not working on Hadoop.
Yeah, you are not.
Linux.
Correct.
So if I put a Hadoop, then only I'm saying that I'm going to the Hadoop and I'm doing this all.
Yes, you're right.
So now what I did here, okay, so coming to your point, like, I put Hadoop, so I'm putting a file from my local to my Hadoop directory.
Correct.
If I want to put the reverse direction, then I don't need to put Hadoop. I just put the, backward.
Get. You need to put get.
So I can put a Hadoop, but I just put the get.
Yeah, get.
Right? I can put a Hadoop, but I can just use, instead of put, just use a get.
Get, and then you need to give the Hadoop location first, target location as a Linux as second.
Right. Okay. I got it.
That's the only difference.
Okay. Yeah, because always I was using this user and here in user, and it's saying like, I frustrated, like, what happened? Lot of time I tried, and it was just like, if you see a lot of time I tried.
It happens all the time. Even for me, when I started, same thing happened. That's why I immediately able to find, because it happens all the time. They have the small differences. It's good.
Yeah, and I don't know, because I see how do I make sure that I'm in a Hadoop or I'm in a Linux?
Correct. Exactly.
So because the pwd command is here and there is same, right?
You don't have pw command in Hadoop because you are not literally in Hadoop command system. You are always in Linux. From Linux, you are going to access Hadoop. So whenever you are going to access Hadoop, you are always going to give full path.
Okay.
Currently, let's say currently you are in /home/cloudera, right? Let's say you want to change the working directory. All you can do is you can write cd space desktop.
Yeah. So that also I did.
But in Linux, you can change the working directory, but there is no such thing in Hadoop as such. You don't have to change it, something like that. Always you are going to give the full path. Because Hadoop is a virtual file system, right? It is not a file system like Linux. It spans across the cluster.
What happened? It's always closing. I'm here. I can put
CD.
Yeah.
Desktop. Dcaps desktop. Dcaps.
Right.
Yeah. If you do PWD, it changes. Do PWD. Yeah. So, but this is not possible in Hadoop. We don't have something as such. We don't have to go into any particular directory over there.
Right. So from here only we trigger we can trigger the command to go to that folders.
Correct. Exactly.
Right. We don't go to Hadoop and say CD or ls.
Correct.
It's all, you're still in a Linux. From the Linux you just fire the commands to go to the Hadoop. Okay. Yeah. That was the confusion, because again I was into Hive. But I want to copy the file because I created a table, but I don't have a data.
Correct. You need okay. Understood. Correct.
I need to get the data, but I need to get the data means first I need to put the data from the using this command, right? Yeah. So every time I'm trying, the put is not working and the get is not. That's why I was like, okay, I'm stuck. I cannot do anything. Because it's showing me, it's all showing okay, but if I select the table name, but again, but there's no data. I know it's a no data, but I don't know how to put the data there.
Correct.
So now I put the data just like a folder, right? like how you put in a Hive folder, because from so that also I do it from the in the Hadoop, right?
Yeah.
I mean, in the HDFS.
Correct.
From HDFS, then I map that file using this table.
Correct. From HDFS, you need to map the table. All you need to do is you need to give the path. Like external table, if you give the same folder name as the location, then it always picks up by itself.
Okay. So what was the command to? So it's just a describe to see the column names.
Column name, yeah. Describe and column name, yeah. DSC and then column name. Give the table name.
Yeah, page underscore view. Yeah. Okay. Yeah, I'll try to load the data and see I can able to map it by seeing the assignment.
Sure.
Right.
Thank you.
Thank you.
Thanks a lot.